In this equation review, we'll go over the displacement equation, speed equation, velocity equation, and also a position equation with constant velocity. So looking at the first equation, we have displacement. Displacement is really similar to this word here, distance. And it's important to know the difference between the two. So if I have a route and I have a starting point and I move 10 meters to the right and then 6 meters back to the left, I would say my distance is 16 meters. Now calculating displacement, I'm just looking for the net difference between the final point and the initial point. So here's my final point. What is my net difference? Well, that is equal to 4 meters. So we'll keep those two definitions of distance and displacement, and the difference between the two, we'll keep those in mind when we look at the difference between speed and velocity. So speed is just taking the distance over the total time. So let's say that this route took me 2 seconds to complete. I would simply be taking 16 meters divided by 2 seconds and getting my average speed for the route at 8 meters per second. As follows, I would find average velocity, which I'll designate as equation 3, by taking the total displacement over the total time. And notice here they're defining displacement as x final minus x initial, which shows the net difference in x. And that's described as delta x here, and where we see that same equation, x final minus x initial. So finding average velocity, I'm taking the displacement over the total amount of time, 2 seconds, where I get 2 meters per second. So as we see, displacement. So because the two definitions are different, we have similar calculations, but the answers end up being completely different in value. So finally, we are going to look at the position equation. So what this is essentially saying is our initial position, which is x naught, given some time at a constant speed, will get you to a new position, which is x. So how would we calculate that? Let's say our initial position here, and I'll draw in blue below the distance and displacement writing. Let's say our x naught position is at 0 meters. And I'm traveling at 4 meters per second. That's going to be my velocity. And if I'm traveling for 3 seconds, what would my final position look like? So I'm solving for x. So a good way to represent velocity, or at least how I like to do it, is bracket the amount of distance you travel per second. So if I'm traveling for 3 seconds, and I know my velocity is 4 meters per second, or in other words, I'm moving 4 meters every second, this represents 4 meters and 1 second. And let's draw 2 more of those, because we are moving a total of 3 seconds. And that's another second. So if we take our final position after 3 seconds, we could just add 4 plus 4 plus 4 and get 12 meters, which is x. So this equation is essentially a shortcut for the longhand notation I just did. We could calculate x by saying our x naught, which is 0, times the velocity times the time, and end up getting 12 meters.